This is the second part of our discussion on SQLite. In the first part, we talked about what a constructor is and how we want to set up our offline plant DAO, which is going to create the database, add data to the database, and then allow us to selectively query the database. When we create a database schema, in other words, when we lay out how we're going to put data into the database, we'll typically have a create statement. And in SQLite, that create statement belongs in the onCreate method. Actually, in our DAO, it belongs in the onCreate method. Now, the create statement is a pretty standard syntax, but if you haven't seen a database before, if you're not familiar with it, it might seem a little bit goofy. I'm going to do this statement in two parts. First of all, I'm going to write it all out as one string, and then secondly, I'm going to chop it up and make some constants out of it, which will make our life a lot easier. So, defining a create statement. What I'm going to do is I'm going to say string schema equals, and then double quote, and we typically do this in all caps, create table, and then let's say plants. So a table, think of that like an Excel spreadsheet. It's where I'm going to save data. And by the way, this onCreate method will be called once and only once. It's going to be called when we try to interact with the SQLite database and it realizes that there is no table there. There is no schema there. So this will be called once and only once. Create table plants, and then I'm going to do an open and close parenthesis, and all of the fields, all of the columns of this table will be defined between the parentheses. The columns, think of Excel columns again. Think of if you had an Excel spreadsheet named plants, then you have a column for genus, species, cultivar, common, so on and so forth. Now, one trick is, what do we want to save here? What do we want to save in this table called plants? What do we want to save in our local copy of the data? Remember, the central database that's in the cloud or on the web, whatever you prefer to call it, that will always be the master list of data. This local database is only going to be used so that we can still perform some functions offline. It'll also be used for autocomplete. This is one of the hardest things for me to figure out when I really wrote the plantplaces.com app, which is how much stuff do I want to store in the local database versus what are we going to just access online. And the real rule of thumb is just store enough data locally so that you can fill in the autocompletes and so that you can do certain functions offline. And the thing I really wanted to be able to do offline is GPS plants. And that's easy because GPS data available over satellite is free and worldwide. So I knew I could always get the GPS data live even if I'm not connected to a cellular network. But the plant data I wanted to have locally so that I could do this GPSing when I was overseas in a country where I didn't have network coverage. So that's what it came down to, was just enough data that I could search on a plant. But not every single picture of a plant, nothing like that. Keep it simple. Let me add a little more punctuation here. We need a semicolon to terminate the string. We also need a semicolon to terminate the SQLite create table line. So a little bit goofy syntax. A good idea to set it up like this right at the start so that you do not forget one of the close semicolons and you don't forget the pluses like so. So within these, what I'm going to do is I'm going to say, let's see, we're going to have a unique identifier locally for this table. We'll call it _ID, which is fairly common. And then we need to say it's a data type integer, and it's a primary key, and we're going to have an auto increment. That means every time SQLite inserts a row into this database, it's going to assign a value to this primary key field that's going to be unique. And every time it assigns a value, it's going to add 1 from what the previous value was. So SQLite will actually take care of that for us. It will take care of assigning that unique identifier for us, which is really nice. I also want to assign, I'll put a comment there because the next column is going to be one called GUID or Global Unique Identifier. And that's the primary key that's coming from plantplaces.com. So that's a global unique identifier where this identifier here is only unique within the local SQLite database. So we'll say GUID, and we're going to call that an integer as well. Okay, and then we'll say genus, and we'll call that text. And then we're going to say, let me scoot this over a bit so you can see the whole thing. We'll say species, and we'll call that text. And then we'll say cultivar, and we'll call that text. So text means alphanumeric data, where integer is whole number only data. And then common, and we'll call that text. So this is what we want. These are the columns that we want to define. Only about 6, and as I said, keep it simple. Keep it simple. Don't overdo what you put in this local database. Just enough that you can do autocompletes, which we will be able to with genus, species, and cultivar and common name, and enough that you can do certain things offline as you wish to do them offline, like in my case, GPSing a plant. Now, one thing that's a bit tedious, but is going to pay off if we do it now, is we want to extract these table names and column names into a set of constants, because we're going to be using them over and over again, and we want to make sure that we don't misspell them. If we extract them as constants now, it's going to make our life a lot easier. The only trick is to do that, we actually need to turn this one long string into a set of smaller strings that are appended together with a plus operator. And that's easy enough to do. If I want to isolate the table plants, I do double quote plus double quote, and then double quote plus double quote. So, whoops, there we go. So what it's done now is it's created 3 different strings now. One called create table, one called plants, and then all the columns that follow. Now what I can do is I can right click, refactor, extract constant, and we'll give this, we'll say plants, well let's see, we'll give it a name of plants table. If we do this now to each of these columns, it's going to make our life much easier. It is a bit tedious, but it's going to make our life a lot easier. So I will do the double quote plus double quote, and I'm going to put that around each of the columns that I wish to refactor into its own constant. So just a little copy pasting going on here, but I'm going to chop this up into a bunch of mini strings. Okay, there we go, and there we go, and cultivar, and common. Okay, and we're all set. Now it's just a matter of going through here, right click, refactor, and whoop, that looks like it doesn't know where I am. So let me click on ID, see if I can, maybe I'll highlight ID, see if that helps. Right click, refactor, extract constant. Okay, fine. Right click, refactor, extract constant, ID, that's good. And move on down to global unique identifier, right click, refactor, extract constant. Okay. By making a constant, I'm centralizing this in one location, each of these words, so that we can freely reuse them when we have other statements, other SQL statements that we're going to create, and we're going to create quite a few. You don't have to do this, but it's certainly going to make your life a lot easier. So just 3 more to go. We have species, refactor, extract constant. Good. Okay. And cultivar, refactor, extract constant, and good. And finally common. Right, let's see, so whoops, off a little bit there. Select, right click, refactor, extract constant, and there we go. Okay, we still have the same original string, but now we have all of these constants up here, which is going to be very nice. Now one trick is, before we can fetch data out of this table, we need to be able to put data into the table. So, all right, so let's say that we have a method. Let's make a new method. Let's say public, whoops, need to take my caps lock off, public void insert plants. And let's say this will accept an array list of plant objects called all plants. Okay? Now what we want to do, and I'll put some JavaDoc to describe this, what we want to do here is given a collection of plants, add all of the plants to the database. We'll even say the local database. Okay. So insert plants, what we're going to do is we're going to iterate over all of the plants passed in so that we can insert them into the database. Okay. This requires what we call a for each loop, which Eclipse makes very easy for us. So we want to take this collection of plants and insert it into the database. So what I do in Eclipse is I simply type FORE, hold Control and hit space, and then hit enter. And it automatically works out this for each loop for me. What this is saying is I'm going to iterate over all plants, this collection here. Each time I iterate, I'm going to take one of the plants and I'm going to assign it to a local variable called plant, and then I'm going to make that useful. So in other words, if there are 12 plants in this collection, this loop will run 12 times, and it's going to touch each plant in order. First plant will be first, second plant on the next iteration, third plant on the next iteration, so on and so forth. So this loop makes it easy for us to access every single plant that's passed into this all plants collection. Okay? So, what I do now is I say, I use something called ContentValues. Okay, ContentValues is a name value pair construction that makes it easy for us to insert data into the database. Okay, so I'm going to say content values CV equals new content values. Okay, and now what I need to do is I just need to let's see, Control Shift O first to get rid of the red line, and content values, there we go. And what I need to do is that I said the content value holds name value pairs. The name is just the SQLite column name that we've just defined and put into constants. The value is whatever we're getting out of this plant record here. So I'm going to say cv.put. Remember how I made a constant for GUID? Okay. And then I'm going to say plant.getID. Okay, there we go. cv.put. And then remember we made a constant for genus, so we can pick it from the drop list here. And then the value is simply plant.getGenus. And then we'll say cv.put. And then again, we made a constant for species. And this is where I said those constants would really pay off. Plant.getSpecies. cv.put. Okay, common. Or let's do cultivar. There we go. And plant.getCultivar. Okay, cv.put. We'll say common. Value. We'll say, whoops, I tabbed too much. Plant.getCommon. There we go. Now we simply insert these values into the database. And for that, what we're going to do is we're going to say we need to call a method called getWritable_database. Get W, I'll type like that. Control space will auto-complete that, so you just have to type get W and then hold Control and hit space. GetWritable_database.insert. Okay, we need to give it a table name. Plants table. Null column hack is kind of goofy. Just pick one of the columns and put it in there. And then for values, CV. And believe it or not, that's all we need to do. It's actually quite simple. We simply populate this content values collection with these name value pairs where the name is the name of the column and the values are the values that we retrieve from the object that was passed in. Now there is one major missing piece though. I just made up this method. Where's it getting called? And the answer is it's not getting called from anywhere yet. So the question is, when are we going to insert these plants? Well, we really want to do it in a way that's fairly invisible to the user. So one thing we might want to do is go back to our plant result activity. And let's take a close look at this. Let's take a close look at this. Do you see line 104 where it is fetching the plants from the online, the central database, the cloud database, the web database, whatever you want to call it? Do you see where it's doing that? What we'll want to do is kill two birds with one stone. As long as we have a collection of plants, why don't we try and save them? So what I'm going to do is refactor a little bit. I'm going to take this offline plant DAO. I'm going to cut it, and I'm going to move it up right around line 100. Okay, and I'll just put a comment here, access to the local database. Now what we can do is on this fetch plants, we can say once we have the plants, store them locally. And we can say offline plant DAO dot insert, well, I guess I should call that insert plants. And we'll say fetch plants like so. So we're killing two birds with one stone here. We're getting the plants so that we can display them, but also we're storing the plants in the local database on line 108. Okay? Now, an interesting thing about a try-catch block, it's not very obvious, but it acts kind of like an if-else test. Okay? If something goes wrong here, it's going to skip everything until it comes to the catch, and then it's going to run whatever's in the catch. On the other hand, if nothing goes wrong here, or if everything goes right, it's going to execute every line until it gets to the catch, and then skip the catch. So how does it work like an if-else? If everything goes well, do this. If something goes wrong, do this. So it's not a very obvious construction, but that's what a try-catch block is. It's kind of like an if-else, where the if part is what you do if everything goes right, the else part is what you do if something goes wrong. And that's why it's safe to put this line here, because we will only get to this line if we have successfully retrieved data from the database. Okay? So, at this point I really want to test this out. But I also want to double check everything I've done so far, because if I do have an issue, it's going to be hard to correct for it. So first I'm going to check my create table statement, and we see create table plants name, open paren, ID, integer, primary key, auto increment. I'm just looking very closely at spelling and also at commas. Then we have the GUID constant is an integer. Genus is text, species is text, cultivar is text, common is text, close paren, semicolon, quote, close quote, semicolon. Okay, just have to make absolutely sure of that. Now we're iterating over our plants, and we're storing them. And, oh, you know what? I did miss one small thing. Okay, I'm glad I checked. This one caught me the last time I did this exercise. On create, I'm going to change this arg0 to db. And what I have to do here now on this line is say db.execSQL and pass it in that schema. There we go. Okay. And save. Okay. Missed that one part. That caught me before, but I missed that one part. Okay. I'm going to set some breakpoints now. I'll set a breakpoint on line 30. And I'll set a breakpoint on line 46. And I'll go back to plant results activity and make sure I still have a breakpoint here, which I do on line 89. So at this point, I'll save. I'll Control M, and I'm going to run this in the debugger, and let's see what we get. I'm excited. Okay, so I'm going to go to Search Plants, and I'm going to choose a plant that I know doesn't have too many results. I don't want it to go too crazy here. So I choose Search Plants. And we're just going to try our favorite redbud. And then I'm going to click on search. Okay, and with any luck, the debugger should pick up soon. Okay, I see the debugger going. Okay, so we are in the plant results activity in the onCreate. I'll go ahead and play through this. Okay, now we're getting our search data. We're on line 89. So this is where we're going to start doing our online search. I'm going to choose F6. Okay, and we'll keep walking through this. I'm going to walk into this constructor. Now watch carefully because I'm going to choose F5, which is step into. In other words, it's this button right here, step into. And that's actually going to take me into the constructor for my offline plant DAO. And well, it looks like I'm not having much luck there. So I'll go ahead and choose step over. And I might have to choose a step return. Okay, let me try step into one more time. Okay. And here's that constructor that we just made where it accepts a context and then it calls this super constructor for the SQLite Open Helper. Okay, it looks like that ran okay. So it's going to take us back now to our plant results activity. And now we're going to do that online lookup of plant data. I choose step over. And that's our network call. So it's going to take a few moments. It's going to put our common name in. It's going to run a network DAO. Okay, get the results. And we've seen this before, but I'll go ahead and step through it. So it's making a network call right now. Okay. And so this will take just a few moments as it calls and tries to get the redbud data. Okay, have our result. Let's see. Should be... Yep, about 12 red buds in there, so we continue. Okay, continue. And now we're parsing out the data. I'm going to choose a step return, which is going to take me back to the calling method. If you're doing if you're doing heavy nesting while you're doing any kind of debugging, the step return just finishes up the method you're in and goes back to the method that called that, which is pretty handy. So we step over, and now here's the real tell. Here's where we're going to try and store the data locally. So I'm going to do a step into on this offline plant DAO insert plants. And what we're going to see is it's going to start to iterate over this collection of plants. And let's see, I'll go up to the variables tab and I'll control M. And what we should see is that all plants will be about 12 red buds. If I did the math right, there we go. We have 0 through 11. And if I expand, we'll see that these are all red buds. Okay, so we have 12 red buds that we're trying to save locally. Let me collapse that again. Control M, take us back to a wider view. Now what's going to happen here is interesting. I'm going to F6, F6. It's going to start to put together this content values. F6, 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 F6. What we're going to see here is it's going to try to write to the database, but it's going to realize that this table does not yet exist. So it's going to invoke onCreate. So I'll go ahead and choose F6. And the next thing that will get called is this onCreate statement that we put together. So I choose F6. And when I do that, I'm going to mouse over schema. I'm going to mouse over that schema variable, and I'm going to grab this entire string. And I'll just paste it into Notepad. Let's see if I can get a clean Notepad window here, just a moment. And we'll see that even though it required a bunch of concatenation, it's still just a normal SQL create table statement. That's all it is. Okay, it's going to create this table. Cross your fingers, hold your breath. Let's hope that works okay. So far, it didn't complain. And F7 step out of. And I'm going to hit play to resume. And if all works well, what's going to happen now is it's going to insert each of these 12 records into the database. Okay, it's going to insert each of these 12 records into the database. And it's pretty boring. One second. Okay, I lost my window there. Just want to make sure it's still grabbing the audio. It's pretty boring because it's going to do this for each of the records, each of the 12 records. So what I'm going to do is I'm going to disconnect this breakpoint, and I'm going to choose play and just let it play through. Meanwhile, how can we see if it actually succeeded or not? Well, remember I told you we have to pass in that context because the context tells us where our sandbox is, what we're playing in. Okay? If I go to this tab called DDMS in Eclipse, it's going to take me to a window here called File Explorer. And in that File Explorer, it's going to show me what this emulator is saving on its local SD card, on its emulated SD card. So what I need to do is navigate to Data, and then once again Data, and then I need to look for the package name that I use to name this application, which is com example fs 13.1046 plant places, and then go to databases and look at that. Do you see that? plantplaces.db? You see that? Okay. What I can do is I can hit this button, pull a file from the device. I can hit that button and copy this file locally to my computer. Okay? I'll just save this under Plant Places DB under Jones Brandon and maybe My Documents. Yeah, we'll save it under My Documents. And we'll choose, let's see, first of all, I'm going to copy the path into the buffer, and then we'll choose Save. Now, what I'm doing is I'm just saving a copy of this database locally. Just saving a copy of this database locally. What I can do now is I'm going to run out and find the SQLite viewer, which is a freely available program that will show you what's in a SQLite database. So I've copied the SQLite database locally, and now let's see. I always have to make sure because all these download sites, they have all kinds of download buttons. Half of them are ads, so I think this is the one we want. So I'm going to click on download, give it a moment, shouldn't take too long, and what it will do, okay, it's thinking, what it will do is I can open it up, unzip it, and then I can inspect that database that I just created. So we'll give it a few more moments to download. Okay, it's downloaded, it's a small zip file. I'm going to hold down Windows key E. Oh shoot, and this is usually when the microphone starts. Sometimes if I go to Windows Explorer, the microphone stops, so I might need to, if that happens, I might need to pause this recording and pick it up later. Let's see, I'll try my best here. I'm going to store this on C, and then Programs. Okay, and you know, I might even actually already have this. Let's see, SQLite Browser. 1 second, do I already have that? Oh, I do. Okay, look, I've already installed it. Okay, cool. So I'm going to click on SQLite Browser. So that's just an unzipped version of the guy that I just downloaded. I'm going to choose Open, and I'm going to go to the same path. It was Jones Brandon, and then My Documents. Okay, in My Documents, I'm going to choose plantplaces.db. Okay, which again, if you look at the date, this is right now when I'm recording it. I hate to admit, yes, it is 11:22 at night. I choose Open, and look, I have a table called Plants. I choose Browse Data. I'm going to look at Plants, and wow, take a look at this. This is the local data from the emulator, and as luck would have it, it is the 12 red buds that I just searched on and were just downloaded. Okay, it was the 12 red buds that I just searched on and was just downloaded. Now, there are over 2,000 plant records in Plant Places, so we're not grabbing them all at once, but we are grabbing them one at a time as we get them. Okay, so let's look at the columns. We have the local unique identifier, then we have the global unique identifier for Plant Places. For example, Cercis chinensis, Chinese redbud, is 542. If I go back to my browser and I put in 542, this should bring up the Chinese redbud. Okay, and there we go, Chinese redbud. So there's the Plant Places identifier. We have the column for genus. Because these are all redbuds, they're all in the genus Cercis. And then the species, again, the species for most redbuds is canadensis, but not all. As you see, the Chinese redbud is a slightly different species. We have the cultivar, and we have the common name, just as we promised to do. So we're nearing the 30-minute mark, which is, again, when I want to start cutting off a video. What we're going to see in our next presentation is how we can do something like this. Select star from plants where, let's say, species like chine for chinensis. Execute query, and what we'll see is we'll get back exactly one result, and that is the Cercis chinensis. So we're going to see how we can take a large set of data and then query it for specific search terms. So today we talked about the SQLite Database Browser, which is quite nice, quite handy, easy to download, very easy to install. We talked about the sandbox, where it's going to store our local data so that we can't interrupt any other program or access any invalid data from other programs, and similarly they can't access our data without our permission. And we looked at how we could use this content values to very quickly and very easily insert data into a database. We also saw how we could kill two birds with one stone. When we download live data, we're throwing it into this insert plant method so that we can save that live data locally, so that we're not downloading the entire catalog of data all at once, but we're just saving it as it gets downloaded for other purposes, which is a fairly efficient way to do things if you want to make a local copy of data that you're getting from a central source. So that's all for this segment. In the next segment, we will take a look at how we can fetch data from the database using this fetch plants method and some standard SQL. Thanks again for listening.